Hello, and welcome to Lesson 5.2a, Writing Equations in Standard and Point-Slope Form. Today's lesson is going to focus on the second part of that, point-slope form. Our objective for the day is that I can write equations of lines in point-slope form. Now, you might be asking yourself, Mr. Boland, what is this point-slope form that I've heard you reference over and over again as we've seen different equations that we were solving? You kept telling us they were point-slope form. What is that? Well, it is this generic form that you see here. Y minus y1 is equal to m times the quantity x minus x1, where m is my slope, so that is my slope, and x1, y1 is a point that is on the line. All right, so you'll notice, let's just kind of zoom in on the equation itself, right? So we have y minus y1. So if our y1 value is a negative, we're going to have a double negative. We're going to have minus a negative. If our x1, if at our x value of our point is a negative, it's going to be minus a negative, double negative. And when you subtract a negative, it is the same as adding. So that's just something that we need to keep in mind here. This is one of those lessons where being able to track your negative signs and pay attention to them is going to be super important in order for you to get the correct responses. So let's just jump right in and write an equation in point-slope form given a point and given the slope. So previously, I told you that you needed to substitute in 2 and negative 10 in for x and y in slope-intercept form so that you could find the b value, and that's how you could write a line knowing a slope and a y-intercept, or slope and a point. Well, in this case, we're going to write it without having to do all that. So we have a point and we have a slope. Our slope is -4, our point is 2, -10. There's that negative sign, so we need to pay attention to this. So, generic form of point-slope form, y minus y1 is equal to m times x minus x1. Why do I always rewrite my original equation? Because it gets me in the habit, and it's something that helps trigger it in your mind so that you can remember it and you can focus on it and you use that value or use that generic form and you're more familiar with it. So our y is going to be minus -10 is equal to my slope, -4, times x minus my x value, 2. Now, if I want to simplify this further, I'm going to write it like this. I'm going to fix the double negative, so y minus -10 is the same as y plus 10 is equal to -4 times x minus 2. Now, I was told to write the equation in point-slope form, which is what I did. I can stop right here. I do not need to convert. Do not need to distribute. I don't need to solve for anything. Right here is all I'm asking you to do. Write the equation in point-slope form. So, letter B. Let's highlight our important pieces of information. What is the equation of a line with a slope of 1/3 and it's going through the point, -6 and 4? Hey, that looks like a problem we've done before. But let's write our generic form. Y minus y1 is equal to m times x minus x1. Now, I'm going to substitute in the values that I know. We have y minus y1 is 4 is equal to my m, my slope, 1/3 times x minus my x1 value is -6. So now to simplify this, we need to just rewrite it as y minus 4 is equal to 1/3 x plus 6. And we rewrite it just because the double negatives is, it's ugly math. We don't want to do that. We want it to be nice and clean, and this equation right here is nice and clean. Letter C, we're going to write an equation for a line that is passing through 8, -4. So that's my point, 8, -4. We're giving it to you in a different order in this question. And it has a slope of 2/3. So we're going to start off y minus y1 equals m times x minus x1. And I'm going to substitute in the values that I know. Y minus, my y1 is negative 4, is equal to m, my slope, 2/3, times the quantity x minus my x1 is 8. And we close the parentheses. Now, again, I see a double negative here. I want to clean that up. So it's going to be y plus 4 is equal to 2/3 x minus 8, the quantity x minus 8. Now, letter D, we want to write an equation for a line that has a slope, has a slope of 3, but we're going through the point 1, negative 4. And so now we set up our equation. Y minus y1 is equal to m times x minus x1. We're going to substitute in what we know. Our first y value is negative 4, is equal to my slope 3 times the quantity x minus x1 is 1. And now we just need to rewrite it again, being mindful of the double negative. So y plus 4 is equal to 3 times the quantity x minus 1. All right, that brings us to our 2 U-try problems for this section. Go ahead and try E and F on your own, and then come back and check your work against mine. Letter E, we have y minus y1 is equal to m times x minus x1. And we're going to substitute in our values. We have 3, 5 is our x value, or our xy value, and negative 2 is our slope. So we go ahead and fill in what we know. Y minus 5 is going to be equal to my slope, negative 2, times the quantity, x minus 3. And we don't have any double negatives here, so there's nothing that we need to do to simplify that. That is our form that we want it to be in. Letter F, we identify our information. We want to write an equation for a line passing through the point 5, negative 3, and it's going to have a slope of negative 3/5. So y minus y1 is equal to m times x minus x1, and we substitute in y minus negative 3 is going to be equal to negative 3/5 times the quantity x minus 5. And there is a double negative there that we need to simplify, so it's y plus 3 is equal to negative 3/5 times the quantity x minus 5. Now, for example 2 here, we are given 2 ordered pairs instead of being given a slope, and we're going to write it in slope or point slope form. So now we need to go ahead and first find our slope. We're going to calculate that first. So we have slope is equal to, we've got 7 minus 5 over 8 minus 4. And 7 minus 5 is 2. 8 minus 4 is 4. And that's going to simplify to 1/2. So now we write that into our generic form. Y minus y1 is equal to m times x minus x1. Now, you might be asking yourself, Mr. Boland, which of these points do I need to use? Well, it doesn't really matter. As long as you're consistent with it, and I'm going to just say I'll pick the first one. So we have y minus 5 is equal to our slope 1/2 times x minus, and we need to use our x value, 4. So as long as you are consistent with which point you are using and you're only using one ordered pair, you will be correct. So there would be an alternate way of writing this. There's a secondary solution here. You could have written y minus 7 equals 1/2 times x minus 8. And when we do some examples later, I'm going to prove to you that these are the exact same, exactly the same. So let's just work on that for right now. Just accept it and we'll prove it a little bit later on. All right, letter B. First, we need to find the slope. y2, -1, minus y1, -3, over x2, 6, minus x1, -1. And we are going to get -1 minus -3. -1 plus 3 is +2. And 6 minus -1 is 7. So y minus y1 equals m times x minus x1. And we substitute in the values we know. Y minus, I'm going to use the first point, just so we're being clear. I'm going to use that as my y1. So we've got y minus -3 is equal to my slope, 2/7 times x minus -1. And when we clean it up to get rid of the double negatives, it's y plus 3 is equal to 2/7 x plus 1. There is a secondary solution or an alternate way of writing it. If you had chosen the second ordered pair to use, it'd be y plus 1 is equal to 2/7 times the quantity, x minus 6. And again, I want you to just trust me. They are exactly the same. When we do another part of this lesson, I will demonstrate to you that they are exactly the same. All right, on the top of the next page is 2u try. Actually, no, not 2u try. 2 more with me. So we've got our equation. We need to find our slope first. We've got -3 minus -7 over 6 minus 2. -3 minus -7, that's -3 plus 7 is 4. 6 minus 2 is 4. 4 over 4 simplifies to 1. And now I'm going to go ahead and just substitute directly into my equation. I'm not going to rewrite it because that's getting a little redundant, and I'm going to use the first point. So we have y minus -7 is plus 7 is equal to my slope, 1 times the quantity, x minus x1, which is 2. There is that secondary alternate solution. Y plus 3 is equal to 1 times x minus 6. So both of those equations are correct. One is using the first point, one is using the second point. They are equations for the exact same line, though. Letter D, write an equation for a line passing through the points -16, -18, and -11, -2. So we first need to solve for our slope. Slope is -2 minus -18 over -11 minus -16. So -2 minus -18 is going to be a +16 because we're adding 18. And -11 minus -16, we're going to get a +5, which we're just going to leave exactly as it is. Now we write our form. So we have y, and I'm going to just tell you I'm using the first ordered pair as my values. So we have y plus 18, because it's double negative, is equal to my slope, 16 over 5, times the quantity, x, and it's going to be plus 16, because again, there's double negative there. So that is one of my ways of writing this. My alternate way would be y plus 2 is equal to 16 over 5 times the quantity, x plus 11. Again, two equations for the exact same line. Now we're brought to our two U-try problems, letters E and F. Go ahead and do those on your own, and then check your work against mine. Letter E. First, we find our slope, negative 3 minus 5 over negative 4 minus 2. So we've got negative 3 minus 5 is negative 8. Negative 4 minus 6 is negative 6, and that equals 4 over 3, and our negative signs cancel out. So now I can write my equation, and we're going to do it same thing. First one is going to be first. So we have y minus 5 is equal to our slope, 4/3, times the quantity, x minus 2. And we close out our parentheses. And again, we have our form using our second ordered pair. So that would be y plus 3 is equal to 4/3 times the quantity x plus 4, again, because of the double negatives. And letter F, write an equation for the line passing through the points negative 2, negative 3, and negative 1, negative 7, negative 1. So we find our slope first. M is equal to negative 1 minus negative 3 over negative 7 minus negative 2. So negative 1 plus 3 is going to be 2. Negative 7 plus 2 is going to be negative 5. So we have negative 2/5 as our slope. And so now we substitute in. We have y, and again, I'm using the first point first. So we have y plus 3 is equal to our slope, negative 2 over 5, times the quantity, x plus 2. And we have a second form of the line, so that's going to be y plus 1 is equal to negative 2/5 times the quantity, x plus 7. All right. Now we're going to go to our next part, which is example 3, changing to slope-intercept form. Now, this is where you can see, or you'll be able to see how these equations can be converted and can be manipulated a little bit. So if we have letter A, we're going to take a look at it. My first step that I'm going to want to do is distributive property on the right. So I get y minus 1 is equal to negative 2x minus 6. And this is all work that we've done before. We add 1 to both sides. Y is equal to negative 2x minus 5. So again, this is work that we have done before. We have solved these kinds of equations. We've done this kind of a process. And now we're just going to see that this is taking from one form to another. So if I'm specifically asking you for something in slope-intercept form, and I give you a slope and I give you a point, or I give you 2 points, you are absolutely able to, at this point, now write it using point-slope form and solving for the equation. Now, that seems to be a whole lot less work than if I were to say, with my ordered pair is going to be a negative 3 and 1, and a slope of negative 2. If I wanted to do y equals mx plus b, well, then it's going to be 1 is equal to negative 2 times negative 3 plus b. So that'd be 1 is equal to 6 plus b minus 6 minus 6. Negative 5 is equal to b. Y equals negative 2x minus 5. This is your more efficient route. This is the route you would want to take on a test, especially if the test has a time limit to it, because it is more efficient. We wanted you to be able to understand and how to solve for b and manipulate and work with the slope-intercept equation. Point-slope form, its biggest advantage is the ability to write an equation knowing one point that is not the y-intercept and the slope. So those 2 pieces of information, you can write an equation for any line that you ever need. And we can see the difference in the work right here side by side. Now, letter B. we have y plus 7 is equal to 3x plus 1. So we're going to go with distributive property first. Y plus 7 is equal to 3x plus 3. My next step is going to be subtract 7 from both sides. Y is equal to 3x minus 4. All right. Now I want you to work on letters C and D on your own, and we will go over them as a group. Letter C. Our first step is distributive property on the right side. So we have y minus 5 is equal to 2/3 x. 2 times negative 6 is negative 12, divided by 3 is minus 4. And my next step is to add 5 to both sides, and I get that y is equal to 2/3 x, and that's plus 1. Now, letter D, if we're going to use that same approach, distribute first, we get y plus 2 is equal to negative 4/5 x. Negative 4 4/5 times negative 15, that's going to be plus 12, because it'll be negative 4 times negative 15 is positive 60. Positive 60 divided by 5 is 12. And now we need to do our final step of subtracting 2 from both sides and get that y is equal to negative 4/5 x plus 10. All right, so now we're going to go on to our next page, and that's going to be applying point slope form. So we have Nadia's book club is ordering new novels. She knows that the cost of 5 books is $61.25, and 15 books cost $159.75. Write an equation in point slope form to represent the total cost y of ordering X books. Well, first off, I have my variables defined for me. That's always an important thing. Total cost is y, and we're ordering X books. Now, I have a point. I have 2 pieces of information. 5 books is $61.25. 15 books is $159.75. I can calculate a slope from that. So my y values are my costs. So I'm going to take 159.75 minus 61.25 over 15 minus 5. And when I do that subtraction, I get 98.5 over 10, which is equal to 9.85. We can go with a decimal since we're dealing with money here. And now I want to write, it says write it in point slope form. So I think that's an important thing to highlight here. Write the equation in point slope form. So we have y minus one of our points, let's go with 61.25, is equal to 9.85 times the quantity, x minus 5. You have a secondary equation you could write, and it would be y minus 159.75 is equal to 9.85 times the quantity, x minus 15. Okay. Now, let's look at letter B. During a trip to Belgium, Jerome and a few of his friends exchanged their dollars for euros at a bank. The table shows how many euros each person received after paying the bank's fees. Write an equation in point slope form to represent this scenario. All right, so what's happening here? Well, we've got our variables, dollars and euros, and I want to find my slope, so I'm going to just go with my 2 biggest values, I'm going to say that my slope is going to be 122.1 minus 99.75 over 150 minus 125. When I do that, I get 22.35 over 25. And when I simplify that division, I get that it's 0.894. Now I'm going to write my equation. So we have y minus, well, there's three different ordered pairs we could write here. So we could do y minus 122.1 is equal to 0.894 times the quantity x minus 150. That's the first one you could write. The second one you could write y minus 108.69 is equal to 0.894 times the quantity x minus 135. There's the third way you could write it. Y minus 99.75 is equal to 0.894 times the quantity x minus 125. Now, I don't care which of the 3 points you choose. As long as you write it appropriately and correctly, it does not matter which point you use in your solving. Either way, I am good with. All right, letter C on our taxi cost here. So we've got the total cost of a taxi fare is given in the table. Write an equation in point-slope form that models this situation if x represents the distance in miles and y represents the cost in dollars. So we have x is miles, y is dollars. We need to find a slope. And so if I do this, my slope is equal to, we got 34.85 minus, I'll take my lowest, 690, over 1225 minus 1.5. So our dollars over our miles. And we get that it's 27.95 over 10.75. Do that division and you're going to get that it's 2.6. Now, I'm going to be able to write multiple equations here. I'm going to pick the first one and I'm going to pick the last one. So I'm going to pick the first equation or first ordered pair. So y minus 6.9 is equal to 2.6 times the quantity x minus 1.5. Okay. My second equation that I could write, I'm going to pick this one here, which would be y minus 22.5 is equal to 2.6 times x minus 7.5. Now, how about we use this one to prove to you that what we're getting in these equations is going to be the same equation. So the first thing I'm going to need to do is I'm going to need to multiply 2.6 by x and by negative 1.5. And I'm going to get y minus 6.9 is equal to 2.6x minus 3.9. And then I'm going to add 6.9 to both sides. And I'm going to get that y is equal to 2.6x plus 3. Now, if I look at my purple equation, right, we're going to do the exact same step with it. We're going to distribute. So I'm going to get y minus 22.5 is equal to 2.6x times negative 7.5, and that's going to be minus 19.5. And then again, we're going to add 22.5 to it, and we are going to get, surprisingly, drum roll please, y equals 2.6x plus 3. So, and you can just take my word for it that if you used 4 and 1340 and 12.25 and 3485, you are going to get the same value. A slope of 2.6, a y-intercept of 3. What does this mean? You're getting charged $2.60 per mile that the cab takes you, and it costs you $3 to pull the cab and get him to pull over and start driving you. So that is a prime example, and working our way through and seeing that these two are exactly, in fact, equivalent equations. All right, so letter D. We have the table shows the number of gallons of water, Y, in a tank after X hours. Write an equation in point slope form that models this data. Okay, so let's do this. We want our equation in point slope form. So I'm going to start with my starting amount, my highest value of my Y value. So we're going to say time is X and gallons is Y. So we have 10, 820 minus 3320 over, we have 8 minus 2. And when we get this, we have M is equal to 7,500 over 6. So M is equal to 1250. My equation, if I just take, I'm going to take, let's say the first ordered pair. We're going to do y minus 3320 is equal to the slope, 1250, times the quantity, x minus 2. You could have picked any one of these four equations or ordered pairs, and you would have gotten the same equation. Now, there's a secondary part to this question. What does the slope represent? What does the slope represent? It's 1,250 gallons per hour. And if you'll notice, as time is going on, we are increasing. So it's 1,250 gallons per hour increase in the volume in our water tank. Now, we got a picture here, and I just included this to show you. So this is a water tank that's on top of a building in the city of Chicago. Why do we have these big tanks of water on top of the buildings? Two reasons. Number one, it helps provide water pressure for that building. It's an old way of doing it when wells weren't as common or as quality as what we have today. Secondly, this is a fail-safe way of having fire sprinklers in a high-rise building if there's no power, because this is gravity fed. So all it has to do is this is plumbed into your sprinkler lines. If there's a fire in an apartment, the sprinkler opens, that valve starts releasing the water, and even if there's no power to pump water to the city, you are still able to get water to fight that fire as it just drains by gravity into the spaces that are on fire. So that is why you see these water tanks all over a city like Chicago. So that's just something as you're driving around the city and you notice, that is an old school way of firefighting in a high rise that has been around for hundreds of years. Not hundreds of years, about 100 years. All right, we're going to go on to the next page, and it is going to be graphing using point slope form. Now, you may have seen me pull out a point from one of these when we were converting it to slope intercept form, and I extracted a point, and you might be kind of figuring like, well, how did you do that, Mr. Boland? So let's remember our generic form. Y minus y1 is equal to m times x minus x1. And I purposely tried to write these underneath the values that they're going for. So my slope is going to be really easy to identify, right? It's m, it's right there. So my slope is negative 4 over 5. Now, my point is a little harder to identify, and it's because of the signs, right? So we have x minus 4 and we have y plus 7. Well, x minus 4, I know my x value, that's just exactly what I see there, right? So my x value is going to be 4. Well, but what about my y value? My y is supposed to be minus y1. Well, if it's plus, that tells me that I have that negative, that double negative, and so it's 4, -7. How does this help us graph? Well, we don't have to convert to slope-intercept form because sometimes that'll give us an intercept that's not very clean. Here we know I have a clean point that I can work from. So we go to the point 4, -7. So to the right 4 and down 7. That's my starting point. And I'm given a slope that I can follow a pattern from. And as I look at it though, down 4 and to the right 5. Do I have enough room on my grid to go down 4 and to the right 5? No, not really, but we can work our way backwards up the pattern. So instead of going down and to the right, our backwards way would be up and to the left. So we're going to go up 1, 2, 3, 4, to the left 5. Up 1, 2, 3, 4, to the left 5. All right, and that gives us 3 points. It's not the ideal for us to graph a line, but is enough that we can work with. So we have our points, and there we go. Arrows on the end of the line as is expected. Now, can I go through the work and solve this for slope-intercept form? Absolutely, I can. But you're going to get a y-intercept that is not a clean point. And that's the point, or that's the reason why point slope is helpful. So we would have y plus 7 equals -4/5 x, and it would be plus 16/5. So you can see how that is, that's not going to be a really solid point for us to try to graph with. As soon as we start working with it, we've got y is equal to -4/5 x, and let's see, that would be 16/5 minus 7 is -3 4/5. So you can see we're somewhere between -3 and -4 where we cross the axis. Is that going to be something I want to graph in slope-intercept form? Absolutely not. This form is a much cleaner form for me able to graph than this one is in this instance. So when I see that I have a clean point, I'm going to want to just extract it and use it. All right, so let's look at letter B and let's extract our point from it. So we have a +3 and we have -4 and we have 3 as our slope. So my slope is 3. My ordered pair is going to be a -3 because it's positive in the equation, so we take the opposite sign of it, and we have 4. So we're going to the point -3, +4. And my slope is a +3, so I'm going up 1, 2, 3 over 1. Up 1, 2, 3 over 1. I have the bare minimum points. I do like to have some more, so I go down 1, 2, 3 to the left 1, down 1, 2, 3 to the left 1, down 1, 2, 3 to the left 1, down 1, 2, 3 to the left 1. And now I'm able to draw my line in. And we have our arrows at the end, and we are good to go. All right, last 2 problems. I would like you to try them on your own. Go ahead and get started. All right, so for letter A, we're going to find our slope, which is really easy. It's 3/4. My point, we have a +8 and a +2. Ooh, that tells me I have double negatives here. So my slope is 3/4, and my point is -8 and -2. So we go to the left 8, and we go down 2, and my slope is a +3/4. So I'm going up 1, 2, 3 to the right, 1, 2, 3, 4. Up 1, 2, 3 to the right, 4. Up 1, 2, 3 to the right, 4. Up 1, 2, 3 to the right, 4. And now I can connect my dots. Now, is this an equation that would be easy to solve in slope-intercept form? Yes. Because my x value, I see I'm going to end up with whole numbers because 3/4, if I distributed to the 8, 8 is a multiple of 4, so it simplifies very nicely. And we see we have our y-intercept here at 4. All right. Letter B, we have y plus 3 equals -2 times the quantity x minus 2. So we're going to go ahead and we are going to find our point. So my point, we've got a plus 3 and a minus 2. My slope is a minus 2. So we have an ordered pair of 2 and -3, and we have a slope of -2. So we go and find our point, +2, -3, and our slope is -2, so we're going down 2 and to the right 1 each time. So down 2, right 1, down 2, right 1, down 2, right 1. And we can work our way backwards, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. And I can follow this pattern all the way to the edge if I really want to. And I did. And so we draw our line in, and there we go. That is the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.